start. Good evening, everyone. Let me present to you our today's speaker. It's Marchenko, PhD student at the University of Mannheim. Maria, the floor is yours. You're welcome.
Thank you. Thank you for having me here, and thank you for coming. So today I'm going to talk about my recent paper, which discussed the endogenous shocks in the social networks, and in particular the exam retakes in their university framework. I'll start with a short introduction, and then I'll introduce to you the econometric model that I'm proposing, and I will talk about the empirical results that I got. So first of all, we all can agree that social connections matter and that the peer may influence our own performance in one or another way. So there's a broad literature discussing the peer effect in the education, in labor market, and everywhere. But I want to look into on the networks in a little bit of a different manner. So I want to see the network as some sort of channel that can transmit some sort of shock or treatment, if you want. So for example, if something is happening to one of the agents in the network, that may further spread onto the performance of the other people. In particular, in my empirical example, I'm looking into the failures in the university. So I'm assuming that if somebody unexpectedly failed the exam in the university that may influence the future performance of the friends. So that it may serve as their wake-up calls, suggesting that maybe university is a little bit more difficult than the students thought at the beginning, or it may, on the contrary, put the student in a situation when he spends a little bit more time with the person who failed the exam and distract him from their own studies. So that will have some influence on the future performance of the of the friends. So the econometric model that I'm proposing is one important thing is that usually those treatments that are discussed in the literature that they are exogenous, so they are randomized. However, the retakes are highly endogenous in the university framework. So the probability of the person to have a retake on the exam is dependent on their peer group initially. So that's why it's a little bit more complicated to identify the effect of this shock, of this endogenous shock, on the future performance. So the model that I'm proposing can be further extended onto their a little bit more broader set of problems, not only in the university problem, but also, as I already mentioned, some sort of treatment effect on untreated, but with the situation where the treatment is not randomized when it's endogenous. Why do we care about the retakes? Why should we study them? Of course, it's much more interesting to discuss the dropouts from the university, because they are the sunk cost of the university. So according to some studies, universities are losing billions of dollars in sunk cost when students are dropping out of the university. So for example, in 2010, the estimation sunk cost of the universities in Australia were 1.5 billions of dollars. And in Germany, it was up to 12 billions of dollars. And but dropouts are not present in the network throughout all the time of our studies, because once people are out of the university, they're no longer in the survey. So we cannot really track all the people who are out of the university for the whole duration of the studies. But the retakes are the most frequent reason of the dropout. As you may know, in High School of Economics, 3 retakes will lead to automatic expulsion from the university. So the retakes can serve as the best approximation of the dropouts. Moreover, universities can control the threshold of the retakes, and if there is enough evidence that the retakes influence not only the person who are retaking the exam, but also spread further to their circle of friends and influence these friends as well, that may suggest to the university that maybe they can manipulate the threshold and adjust the amount of people who are at the end will drop out. So what is new in this project in comparison to the existing literature? I'm not studying the pure peer effect that is usually studied, that is quite often studied, but I'm interested in the effect of, okay, the pointers now, on the effect of shock on the future performance. So I'm really much more interested in this particular shock and not of the pure peer effect. And that's why I'm proposing the new type of model, which is a two-step model I will show you later. And this sort of model allow to have the endogeneity of shock and allow me to identify this shock. So I'm applying this model to the unique data set, and I can show you the new results for the literature. I think I just switched off it. Doesn't work anymore. No. Okay. Okay, so just in case we don't make it until the end of my talk, I want to preview the results briefly. So I'm able to get the identification of the effect of the shock that I'm interested in, and also the identification of the endogenous peer effect that is usually studied in the literature. And this identification is achieved under quite reasonable assumptions. So first set of assumption follows directly from their peer effect literature, and it's similar to what is studied in a paper by Braumollet and co-authors, and it requires the presence of either intransitive triads or the distances of minimum length 3, depending on the type of model we're using. So what is the intransitive triads? Intransitive triads is the existence of 3 students in the network that are not connected, the 2 of which are not connected directly, but only connected via this one student. So if we have several of those intransitive triads in the network, enough of the intransitive triads, the identification will be achieved. If we assume the correlated effects in the network, which I will show you, which I will talk about a little bit later, we will require a little bit stronger assumption, which is the distance of minimum length 3, which means that we want to have 2 students that are connected via 2 links. So not via 1 person, but via 2 people. So the shortest way from this person to this person will be via 2 more guys or girls. And the second assumption is, the second set of assumption is new, and this assumption is crucial for identification of the shock itself. We need the variability of the network. We need the network to change in time. However, it's important that these changes of the network are not only endogenous, so they are not due to the shock that is happening in the network. So if these assumptions are fulfilled, then I'm able to identify the shock and the endogenous effect, and to construct the consistent estimator. And to preview the empirical results, so on average, the unexpected failure of the friend leads to the worst scores in the future, in the next periods. And for example, the 50% prediction mistake, meaning that I'm not sure about how this person will perform, so I'm saying he will 50% he will fail. And if he fails, this means that my prediction mistake is 50%. This can lead to up to a 30% change in the standard deviation of my future performance, which will account to 0.4 of average grade. This differences so different value of differences is depending on how many more friends I have. So if I have only 1 friend, so my average failure will be up to 0.4. If I have 7 friends, it's going to be much lower. And if I only make a mistake in 1 friend. I will continue with the econometric model. So first of all, let me briefly introduce the standard peer effect model in social networks, introduced by Mansky and then further developed in many papers. So here we have the outcome variable, in our case, could be thought as average scores, which depends on the outcome of the friends of the peer group, and depending on the exogenous characteristics of the student themselves and their friends as well. One more thing is that usually we have a correlated effect, which means that some small subnetwork of the big network can be driven by some similar unobserved characteristics. For example, if we have, as in our case, several departments in one sample, different departments can be driven by different unobserved characteristics, and this will be correlated effects. So in my paper, I discuss both model with and without correlated effects for. And yeah, here in this presentation I will talk about the model. In the econometric part I will talk about the model without the correlated effects for simplicity. Okay, I think maybe I should skip the details on the Bromley model and go directly to my model. So what I'm proposing is that, first of all, I'm changing the baseline model in such a way that instead of having the outcome variable of an average grade, I'm having the binary variable 0, 1, whether the person has retake in the first period, and at least one retake. And this binary variable dependent on their outcomes of the friends, not on the binary outcomes, but on the grade itself, because it's more informative in a way. So it has much more information than just a binary variable. Then, of course, we have exogenous characteristics of the person themselves and exogenous characteristics of the friend, and maybe correlated effect depending on the model. So what I'm assuming is that the predicted part of this variable having or not having a retake will not have much influence on the person, because on the friends, because the friends, once they can predict that this person will fail, this will not change their behavior in a way. But what will really matter is the unpredicted part, so the residuals of this first stage. So the residuals of this first stage will be crucial. They will count as an unexpected shock, and this unexpected shock will be what will matter for the changes in the future performance. So then I'm constructing the new variable, which is the variable that is averaging among the friends for each person to have like the unexpected error of my prediction for the friends. And then I'm using this estimated to have to be a shock variable, and this kappa is exactly what I want to estimate. So I want to estimate how this shock is influencing the changes in the performance in the future. If you have any questions, yes.
What is the proportion of students who fail usually?
I think it depends. I think it was up to 40% or something. I have it in a descriptive, just a second. So there was, like, in the sample of 320, we had 157 students who had at least one retake. Yes?
Well, I'm just trying to estimate the probability. If, for instance, if I have 10 friends, right, so what is the probability that at least one of them will fail? So is it probable that no one will fail? Right? So if the proportion of failures are not very high in the population.
Mm-hmm.
So in this case, you will not have the.
Yeah, I mean, if I guess if I have 10 friends, the probability that at least one have a retake is quite high.
And what's the average number of friends?
So the average number of friends is 5. So they have in the survey they had 7 lines, but some people were answering a little bit more than 7. So I think the maximum was 13, but the average is 5. All right. So I'm not going to go into the detail of the proof, but the identification of the step 1 is actually follows directly from the same argument that we have in the paper of Braun-Mollet and co-authors, and requires the presence of the linearly independence of these 3 matrices, which is ensured by the presence of intransitive triad, which I discussed earlier. As to estimation procedure, it also follows more or less directly from what was used in the previous, in the proposed literature, in the previous paper by Braun-Mollet, and who followed the paper by Lee in the special autocorrelated to models. So what we want to, so if we look at our upper equation, we see that the covariate G1Y1 is highly correlated to the probability of retake. So this variable is endogenous and requires some sort of instrument to be able to identify it. And this identification assumption suggests that we can use the exogenous characteristics of friends over friends and as the instrument for this variable. So since I'm not connected, the existence of intransitive triads means that some people are not connected to the friends over friends. So the friends over friends will influence my friends, but not me directly. So this will be a valid instrument for the performance of the friends. So that's why in the vector of instruments, we substitute the endogenous variable by the exogenous characteristics of friends over friends. And first in the first stage, we actually estimate not our equation, but equation proposed by Braun-Mollet, in order to get the estimation of this sort of covariate. And yeah, I guess I'm not gonna go into too many details. But once we can update the expectation of the performance of the friends of my friends, then I can plug it in the new vector of instruments and construct the new type of estimator where I already will use the probability of the retake. And this estimator is consistent. So the second step is a little bit more complicated in the proof of identification and estimation procedure. I still need the linear independence of these 3 matrices, which means the presence of intransitive triads. But the additional assumption that I need is that these 2 networks are different, so that the networks are changing in the time. So I'll skip the estimation strategy. And I'll talk briefly about the model with correlated effects. So the only thing that is changing is that here we have now a correlated effect, and in order to deal with it, we apply the local Within transformation. So we take the first level of the friends who is influenced by the same unobserved correlated effect as I am. And so by applying this transformation, I no longer have the correlated effect. However, that means that I no longer can use the this first level of the friends as the identifying instruments. That's why I need to use the second level of the friends of friends of friends. And that's how we get the identification, which requires the length of 3 and more. So, talking about the validity of the identifying assumptions, the presence of intransitive triads and the length of 3 is quite standard assumption for the networks, and it usually holds. The network dynamics is, however, a little bit more interesting. So here we can see the 2 waves of in my survey, and we see that the first wave is quite different from the second wave. So we have some clusters that are now connected and were no longer connected, which suggests that a network is changing indeed. However, if we think about why the network is changing, some changes can be driven by the retakes themselves. So if we get some friends who have a retakes, that might mean that we will have different goals in the future. The friend will need to study for the retake, and I will need to study further for the further studies. So we don't spend too much time together, and our links can be broken. The same goes for just for my, I don't know, motivation. So if I see that my friend is not as good as I thought he is, I might also want to destroy this bad link. So there are reasons for the links adjustment that can be connected with the shock that we study initially. However, this is not the only reasons for the changes, and this is important for the identification. So there are natural processes that are happening in the university, of course, that that friends are learning about each other during their studies, and just the changes in the links are happening just as a natural process. Of course, ignoring the fact that network is updated over the time, also due to the retakes, may distort the results a little bit. However, I'm saying that at the moment I'm studying the direct effect of the retake of the shock and not the overall effect of the shock. So if I want to study the overall effect of the shock, I also need to see how the shock is influencing the link formation, which I'm actually doing at the moment. And to convince you that not all the changes are happening due to the retakes, so we have I have small sample of friends here, and the green guy is the guy who had a retake in the first period. So we see that he indeed, or she, I don't know, loses some links in the second period. However, there are also new links formed to the person who didn't have a retake in the first period. So there are links that are formed in a way counterintuitive. And also we have a good guy who didn't have a retake in the first period who lost some of the connections. So that suggests that the changes indeed happening also due to the natural processes in the network, which are exogenous. So now let's move on to the data. So I guess I don't really need to explore under this slide, because usually now I'm talking about the features of Russian higher education, but you're all familiar with it. Let's talk about the data set directly. So I'm using the data set collected by the High School of Economics in Nizhniy Novgorod branch. And there are two quite similar surveys. I'm using the first survey extensively, and it has, well, I have two waves of this survey. I guess the third wave is also already present, and it takes the cohort, the same cohort of students who started the university in 2012, and the survey conducted at the end of every year. The second survey is a little bit different. It has three waves that were happening every 3-4 months, and in a 2013 cohort. So that's why the second survey is a little bit more complicated to, in a timing-wise, to be constructed with the model I'm proposing. I have students from 4 departments, approximately 300 students. And the data consists of two main parts. The first part is the survey itself, which has the self-reported data on friends and on study partners in mathematics and humanities, and also some personal characteristics that were asked. And the second part of the data is the administrative data, which has all the grades of all the students throughout the time of the observations. Also, it has the information about the tuition-free or tuition places that they are studying at, and the information about department, the group, and the way they enter the university, as well as the unified state exam results. So In the sample, we have around 74% of the whole population. So we do have a small problem with the missing observations for the network. However, it might be suggested that those who are not present in the survey, maybe they're not as active and participating in the studies, since the way the survey was constructed. Also, from here you can see the reason why we couldn't actually study the dropouts, because in the first wave only 40% of the dropouts were present in the surveys. So a lot of people who dropped out in the beginning of the year were no longer present when the survey were conducted at the end of the year. So we can't really track their influence in the future because we don't observe their future performance. So talking about the network characteristics, as I already said, we have the first wave has on average 5 friends, and the second wave network is a little bit more smaller, and on average people has 4 friends. So some of these numbers actually confirm that the identifying assumptions are quite valid. So for example, the transitivity is 45%, which says that we have enough intransitive triads. The level of transitivity is the ratio of the triangles that are connected to all the triples. And also we can see that really a lot of links are not present in the network anymore. So only 22% of the links that were in the first period remained in the second period. In the main specification, I'm using the directed network. So basically, so I'm only making a link when somebody says that this person is my friend, and not vice versa. And we see that only 64% of this of all the links are reciprocal. So only 64% of people actually the friends back. However, I also tried the specification when I'm suggesting that all the links are reciprocal. So yeah, I'll go to the results already. So the first specification is the most simple specification when we suggest the absence of correlated effects, and in principle the results are not very significant unless we don't control for too many exogenous characteristics. So when we only control for few exogenous characteristics, I finally get the significant result of the unexpected retake itself. And the magnitude is exactly what I was mentioning. Is if we have a 50% mistake, it goes to up to 0.4 of the average grade. But some of the other results here in the table suggest that some modifications can be made. For example, we see that there's a huge significance of the economics department here, so this suggests that maybe the model with correlated effect is a little bit more suitable, since there is an evident difference between different departments. Oops, I think, yeah. So, yes.
Just for clarification, what does it mean, economics 1 and economics 2?
That's the department of the friends in the first wave and the department of the friends in the second wave. So because we have different set of the friends in the first and the second wave, so that means that if the friends in the second wave are more from economics department, it will influence in that way.
Yeah, but in most cases, I do have friends from the same department, right?
Yes. It just since those are not exactly the same vectors, because I don't have exactly the same set of friends anymore. So the influence of the influence in the second period can be a little bit different than the influence in the first period, in a way. So, however, when I split the samples, the magnitude for the economics department was a little bit higher than in the full sample. but the magnitude for management was with the reverse sign. But I wouldn't rely on this result since the sample is then very small, because in the total sample we have only 250 observations, and in subsamples it's even less.
What is tuition W1 and tuition W2?
It's again, so it's how the tuition of the first period influence or the tuition of my own tuition of the second period. So it's a dummy variable whether I'm paying the tuition fee or not.
Right, but if I pay tuition fee in the first period, it means that 99%
Yes,
that
yes.
you're going to pay in the second period and vice versa, right?
Yes.
So that's basically
Yeah, there are
same.
a couple of, there are really one or two examples when it changed, so when this variable is...
Right, but it means that significance is not really important. Because it's just probably one person who got like all excellent marks and was transferred.
Yes, I agree, yeah. I guess then, yeah, the specification when we don't include it is a little bit more...
Again, the question about the gender. So, if there are any students who...
No, it's but I mean, it's not my own gender, right? It's the gender of my friends. So it depends on what gender of my friends I have in the first period and what gender of the friends I have in the second period. So the I mean, maybe it's a little bit confusing the way I wrote it, but since the average characteristics, exogenous characteristics of the friends are changing in the first period and the second period for me, for a particular person, it can be different. So the other thing that I also did for to improve the results is to divide the samples in a different way, and to divide samples to those who had their own retake and who didn't have their own retake. The effect of the shock itself is not significant in those samples. However, again, I would be very careful because the sample is then much smaller, so it's like 86 here and 100 something here. But what I really want to point out here is that we have a significant endogenous effect, a significant positive endogenous effect in the sample of those who had their own retake, which means that the behavior of the people who had their own retake is different, and not in the way they perform in the future, but in the way they want to improve their own peer group. So they want to probably have the peers who can positively influence them, which suggests again that my further research in the link formation is something that should be done.
Just again, the question about the predication of father. Since the signs change, right, from the first period to the second one, what does it actually mean? How it could be interpreted? So what's happens here?
It's a good question. Yeah. Yeah, I'm not sure. I should probably look in whether I actually. Yeah. Yeah. But it's a good question. And so the other thing that was already mentioned, I estimated the model with correlated effect, so that the differences of the departments which we observed before can be eliminated. So the results here are a little bit more stable in a way that the p-value is always a little bit smaller than 15%, but the significant results is really achieved only when we don't have that much of the controlled variables. So the only way to improve the results was actually to restrict the set of the retakes that was taken into account. So initially the whole analysis was conducted for all the retakes that were in the sample, However, here I was dividing the sample, the retakes only to the more important retakes and less important retakes. So these results are for the retakes that are taken into the on the subject that has ECTS score more than 4. So I was playing a little bit with threshold, but usually those who has a ECTS score more than 4, they are the exams that are lasting a little bit longer than one module, and yeah, maybe even have maybe even 2 years. But those are much more important exams, such as, I don't know, mathematical analysis in economics in comparison to discrete mathematics or something like that. And so in this case, when I only had 1/3 of, when I had 2/3 of all the retakes, the unexpected retake, the shock, the effect of the shock is actually highly significant now. So we, in some specifications, it's even less than 1% p-value, and this suggests the numbers that I was already mentioning in the beginning. Yeah. So I guess I should conclude now. I developed the model of the endogenous shock and the dynamic peer effect model. I proposed the estimation procedure and proved the identification of the results under quite mild assumptions, which I also discussed. And applying to the data set from the High School of Economics, I showed that the effect of this unpredicted component of France exam retake decreases one's own future decreases the future performance of the France in the next period. Yeah, thank you.
Thank you, Maria. Dear colleagues, if you have any questions, you may ask.
Yes.
What can you say about the magnitude of the effect?
It's it's
comparable with other exogenous shocks from other good papers that you know.
So the papers that studies exogenous shocks usually that I know, they usually study quite different things. So it's more something in the development economics, which is not really comparable. So the magnitude, of course, is not that high. So the maximum, if I have only one friend, the 50% mistake will decrease my future performance by 0.4, which is 4% of the maximum grade, which is not much, but I guess it's a little bit too ambitious also to assume that the retake will have a huge influence in the future performance. So, but
yeah, I'm just asking just to compare it.
Yeah, I can't really. There's no real comparison that can be driven, but I guess it's quite. I mean, from my perspective, it's the numbers are quite reasonable, but I might be mistaken. I don't know. Any more questions?
I have a question about, or actually a couple of questions. First is about dropouts. You mentioned that you don't study dropouts because like people drop out and you get no data about them later. But there is basically a very important bias created by those people who like influenced you and they left.
Mm-hmm.
Because your main claim is that people with retake influence your behavior, but you don't include into account those people who might influence even more, right?
Yes.
Which means that there's something committed in the paper, and I think it should be somehow discussed why you can just say we don't take it into account, or at least to discuss what is like.
What would be the direction of the bias?
Exactly. Yeah.
Mm-hmm. Yeah, it's a valid point because basically, so the sample is 320 people, and then the people that I'm studying, they just a little bit less because of this dropout, so they're not in the sample that is estimated at all. So that's a quite valid point that may. I'm not sure which direction would be of which direction of the bias would it be. So it might, if those people actually decrease in the future performance, this would not be captured in the effect of the shock. So this would be captured in the effect of the endogenous characteristics of the initial peer group, I guess. So it shouldn't be of a huge influence on their shock itself, but maybe it will be captured in other elements of the estimation. But I think I need to think about it a little bit.
My another question is about those people who don't have any retakes, but we're very close to that, like got like 4, right? If you get 4, it means that in many cases you almost failed, but you was likely to get like a little bit more and to stay, right?
Yes.
So in some sense you can apply the same logic as you use about retakes, saying that an example of those people who almost failed can also influence the friends, right? Because he was on the border. So why not to look on those people and to see whether those people who didn't fail but were almost about to fail, probably they influence you even more in a way.
Yeah, we talked about it already. Yes, I was trying to do this. I couldn't really construct the proper modeling of how to do it, but I have it in my mind, and yeah, I think it's a good way to prove, to check whether the effect is actually existed.
And also, can you come back to one of your first equations when you discuss the probability of having friends with retakes, and who was asking a question?
Yes, this one.
Yeah. So how you define the probability of having a friend with retake?
So this is basically just a dummy. So that's for the person I, and it's a dummy variable whether the person I had at least one retake. So it doesn't take into account the number of retakes, whether the person has 5 or 6 retakes or just one. So it's all the same at the moment. So for example, this is me. So I'm I, and I had a retake. Assume so this variable will be 1. And then I construct the same thing for every person in my sample, and it's either 1 or 0, and then I run this equation. And then for the friend is taking all of his friends and looking in this equation of all of his friends and taking the residuals of all of the friends.
So what do you mean then when you speak about unexpected retake?
So I guess I'm making an assumption that the person in my network has the same predictability power as me as an econometrician, so he can predict. Yeah, it's a huge assumption, but he's also, the person is also able to predict whether up to this number whether his friends is failing or not, knowing his own grades, the grades of his friends, and etc. etc. So and then the unexpected is something that is...
Yeah, which means that there is an assumption that he knows your friends as well, right? Not only you knows your friends, but your friend knows your friends, right?
Yes.
So he can be perfect in econometrician, but he also needs their information to put into the equation, but which not always the case, right?
Correct, yes. But I guess it's really hard to make the econometrics look like a real life in a way. So I guess it's something that should be either believed into or... Yeah.
Right, it just means that you can try to use a little bit more simple estimation in terms of your friends, saying that your friends, when they estimate your probability to fail, they just look on your grades, not on your friends. Just because they observe your grades, not friends.
Yeah, true. Yeah, that's a good point. Yeah. I guess the simple estimation could also be used. I didn't think about it. Thank you.
More questions? Yes.
Hi, my name is Tim. Thank you very much for your presentation. And I'm I like the idea, that's the reason why I'm here, but I'm still struggling to catch the results somehow. So I have 2 points or issues. The first one is the idea, it's interesting. So you're arguing that my own performance in T or T plus 1 depends on whether somebody in my network fails in the exam, right? In T or T minus 1.
Yeah, but yeah.
Basic idea.
Yes, yes.
So my future performance or delta depends on my individual characteristics and some features of my network.
Yes.
Right? So what I would like to see also as a review is predicted probabilities or predicted change in my future performance over the range of interesting network characteristics. For instance, just real life, how many friends should I have, or how does the number of friends impacts predicted change in my future performance. All other predictors at their means. So just change the number of friends or the background characteristics of my friends in the network. So how does this affect the predicted change in my future performance? So this is what I would like to see, and I think that would help to interpret also the results. Because what I'm also struggling with is your estimation is based on 2 very strong assumptions. The first one is that, for instance, you mentioned that that's me, and then there are 2 people in between, and then there's a 3rd person, and the effect travels.
Yeah, no, it's not exactly.
So a lot of people are involved in the network effect. So, and I'm thinking about my real life. So I know somebody, and he knows somebody. Okay, I understand, but if the other person knows somebody, I don't know him, and so it's a little bit the assumption.
No, it's exactly on the contrary. So this assumption of the intransitive trials means that this person who is why I want friends is not influencing me directly. So I don't care what is happening to this person. So it's the opposite thing, basically. I mean, you can influence, of course, but.
And the other thing is that the effect seems to be rather small. And if I go through the tables, I mean, a lot of things are changing. Signs, significance is changing, and a lot of control. So it brings me back to the first point. So show me some plots.
Okay.
To convince me that this is robust.
All right. Yeah,
but I like the idea, and
it's a good point.
It's good.
Thank you. Yeah, thank you.
More questions or comments?
Yeah, or just to continue what you were saying, that I would also think that the presentation would basically benefit clearly if there are like main claims based on the beginning of this end, saying that what we're exactly showing and why is that.
All right. Thank you.
So I think we should thank our presenter.
Thank you.